The intent of this tutorial is to walk through different spreadsheets and worksheets that are provided to past practitioners to design watering systems. So first off, we'll start with an example here using the simple pressure system design worksheet, which was developed by the Western Area NRCS. Keep in mind that all the values and formulas went into this worksheet are for 1.25 inch PE pipe. So just keep in mind when you're using this is for 1.25 inch pipe and only 1.25 inch pipeline. So we'll go ahead and get started here. Up at the top, you want to go ahead and punch in the landowner name. So for this case, we'll just call it pressure fed farmer, and we'll do Union County. Go ahead and put the designer's initials in there and the date. And depending on which PDF viewer that you're using, it may prompt you to digitally sign here for the approver. Otherwise, you can just go ahead and sign it with pen. So I'll move along here. The objective of this document provides the design and implementation requirements for simple watering systems. All design criteria must be met for the utilization of this document. If those requirements cannot be met, a custom design shall be required. So if that's the case, you can go over to the NRCS spreadsheet that was developed for pressure watering systems, PASS 007 livestock watering systems. We'll touch on that in another video. So associated practices here, we'll check off pumping plant, livestock pipeline, and water well. Just a quick little overview of our example here. We are laying out the pipeline for 2 troughs and a new well and pressure tank in these pastures here. So we'll jump back over, and as you can see, we have livestock pipeline, pumping plant, water well, heavy use area. Of course, we'll have watering facilities in here too. So if there's any other additional practices that you want to add, you could go ahead and type them in over here if you're able to do that with your PDF viewer, or go back in and pen and paper, write it in there. So moving along to the design criteria, this is where all of these answers must be yes to proceed with this design worksheet. So does the water system require one of the following water sources? We're going with a new well. So I'm going to check yes on that one. If an existing well is utilized, does the well yield exceed 5 gallons per minute? I'm going to check unknown on that one because we are not using an existing well. Then step number 3, will the proposed pipeline be directly connected to a pressure tank or within 50 feet? This is a new system, new well, new pressure tank, new pipeline, new everything. We are going to select yes because that pipeline will be directly connected to the pressure tank. Will an electric well pump be used? Not solar. Yes. So aside from the unknown here, which does not apply to our design, we are good to proceed with this worksheet. So we'll move on to the next page. Got a new pressure tank. The existing pressure tank settings, we will put not applicable. And then we'll move along to select or determine the elevation of the pressure tank. So I'm going to hop over to what we've laid out here. And zoom in here. You can see that this darker contour line here is 630 feet. And we have our proposed pressure tank and well right there on about 628 feet. So that elevation of the pressure tank, we're going to go with a buried pressure tank in this scenario. And we want that pressure tank to be buried deep enough that it's protected from the elements and will not freeze during the winter. We're going to go down at least 3 or 4 feet. So 4 feet lower is going to be 624, and that is the value that we are going to use to determine our elevation change. So we'll go ahead and punch in 624 feet. Then we are going to check the elevation of the highest trough in the system. Again, we want to take a look at the contours here, zoom in so they're a little bit more visible. This darker contour line is 650 feet. These are 2-foot contours. So as we go up to the next contour, that's 652 feet. This one up here, 654. So right in between there, we're at approximately 653 feet of elevation. That's our ground elevation. So if we want to get that water up to the trough elevation, which is typically around 1.5 feet, 2 feet, depending on the livestock type. Here, let's say we just have beef cows. So we'll go with 2 extra feet added to the elevation change. So between 655 and 624, that is 31 feet of elevation change. 655 minus 624, we're going up, starting from here up to the trough, 31 feet. So I'm going to hop over to the profile plotter spreadsheet. Pretty straightforward, entering in our site data. We picked Union County for this. Let's say Union Township. Down here, it automatically populates the Conservation District office phone. Might be a good idea to punch in the phone number of the ag technician involved in this project. Surveyor, I'll go ahead and put myself. Although we're not surveying this, we will make that known that we are using LiDAR contours, not applicable for our weather conditions. Then we'll go ahead and punch in the survey that we are going to develop based off of our LiDAR map here. This can be done on any scaled map with accurate topo. So here, again, we're starting at the pressure tank, and I'm going to go ahead and take a elevation and location point at every 100-foot interval. So we go out 44 feet to the elbow, and then another 56 is going to be 100. And again, we're going to punch in that, well, we'll punch in the existing ground elevation because you will see how the spreadsheet works and how it offsets the proposed pipeline and elevation there. So at 100 feet from station 00, we have 630. Again, these are 2-foot contours, so 632, 634, 636. And then another 100 feet will get us to this point right here. Elevation there is between 642 and 644. So we'll go over here and punch in 643. And then another 100 feet around this elbow running up into the pasture along the fence line. We have 650 right there. So that's 648, 646. In between there, roughly, is going to be 647. And that's station 300. And then going up another 100 feet, 652. Say 652.5, because we're not very close to 650 for our next contour line. So at 400, 652.5. And then our last roughly 76 feet, call it 475. We roughly between this contour elevation here, 652, and this one here at 654. So let's say 653. And like I said earlier, this spreadsheet will offset the depth of your water line. Let's just keep it at 3 feet. Depending on your local frost depth requirements, you'll punch that number in there. Length of the pipeline, we went 475 feet from the pressure tank. Waterline size, if you remember, 1.25 inches is what this spreadsheet is set up to size with the design. So on this waterline, we've only got one trough. And I believe for here, gives a couple recommendations on what trough type you could put here. So let's just say frost roof. And then you'll go over to your profile tab, hit scale, hit OK, and then there is our profile starting at 628 at the existing ground elevation. So you can see that blue line, and then offset for a buried proposed pipeline at 625, 3 feet below the existing ground elevation. So that goes right up. So use this to look at the elevations. Again, we're starting at 624, 625, and then going up to 655, because if you remember, you want to go add that extra 2 feet in the trough. Should not affect your calculations much, but you do really never know. This simple pressure worksheet is a very conservative tool to use, so there is a little bit of room for error, but as good designers, we want to be as accurate as possible, which is why we're going to add that 2 feet of the water elevation in the trough. So the elevation of the highest trough in the system, 655. Distance to the highest trough in the system. And again, we're just using this. This is a very simple example. We're just going to one trough, and that distance is about 475. The elevation of the furthest trough in the system, again, 655, and the distance to the furthest trough in the system. One line, one trough that we're looking at here. So this one's relatively easy. It should be known, however, on other examples, other real world projects, we don't only want to factor in the highest trough and furthest trough. We are going to use worst case. So here you have delta elevation, that is change in elevation from our highest trough to the pressure tank. And again, that is 31. And the change in elevation from the furthest trough to the pressure tank, again, that's 31. Has an option here to check an alternative trough location. Let's say that we're still trying to decide where we want to set these troughs. But for this example, that's already been determined through our grazing plan. So I will just punch in not applicable. Okay, now from the water system pressure table, which is right here, choose the pressure switch settings for each of the following and round up to the nearest length and height in the table. The highest setting will be used for this design. So we're going to round this 475 feet to 500. So check our pipeline distance here, round it up to 500. And then our change in elevation, we're rounding up to the nearest height in the table, which right there is, we're at 31-foot elevation change. And we want to go to round that up to 40 feet elevation. And that gives us a pressure switch setting, 30-50 right there. So once we have selected that, just to make that clear, I'm going to change these colors from red to blue because it's good practice to not use red for anything other than as-builts. That way we're able to, once this thing is so successfully built, we are able to differentiate between what is designed and what is actually installed. Okay, so there we go. We have our pressure switch settings. Highest trough pressure switch setting is 50. I'm going to use that for the design. And the furthest trough pressure switch setting is also 50. No alternative here. So we could go ahead and put a line through that. Also a line through the public water tap. Now we are going to check that the pressure switch settings we've calculated for our design will not result in pressures that exceed the pressure ratings of the materials that we would like to use in this design. So we'll go in here. Highest pressure setting is 50. The change in elevation, this does say the lowest trough to the pressure tank. However, in this example, we do only have one trough and we're pumping uphill. So there is no lowest trough for this example, but we're still going to use this calculation to check that we're not exceeding the allowable pressure that is stated in the NRCS livestock pipeline practice specification, which is 72% of the pressure rating of the given material. So if you remember from the in-person past trainings for watering systems, that is what this 0.72 is. And then this 2.3 is 2.31 feet of head pressure per 1 PSI. So anyway, we'll go ahead and put in the 31-foot change in elevation. We'll pull up our calculator here. And we go 31 divided by 2.31 equals 13 plus 50 equals 63. 31. So 88 PSI. Again, that is the pressure rating that everything in our system should be rated for, which should be no issue, being that standard PE pipeline typically comes in 160 PSI. Which again, that is under our limit of 115, so we are good to proceed. I'm going to take another line and cross out the option for public water tap. This design layout summary here is something that the contractor will be able to use to, or well driller will be able to use to correctly size the pump. It is not a past practitioner's responsibility to actually calculate what well pump size we need. We provide this information for the experts, the well drillers, to determine what size pump they need for this system. So we take our high pressure switch setting of 50 times 2.31, and there we have our 115.5 feet. Not to be confused with the 72% of 160 PSI rated PE pipeline. The pump supplier shall size the total dynamic head of the pump, which will include the dynamic head as provided, plus lift head from the pump to the pressure tank, plus friction losses in pipeline from pump to pressure tank. Again, our pressure switch settings were 30-50. I'm going to cross out the public water tap, pressure tank minimum drawdown of 8 gallons, and then our livestock pipeline size, again, is for 1.25 inch PE pipe. And that is meeting our NRCS conservation practice specification of ASTM D2239. So continuing on, number of hydrants, 0 for NA because we're not installing hydrants. Permanent trough, we've got 1, and we're doing a frost-free trough here. Permanent troughs require gravel HUA around perimeter. We did check that off at the very beginning. Up here, that heavy use area is also included in this design. Total length of the pipeline to install is 475 feet, and the water source is from a proposed well. So there you have it. Quick little overview of the simple pressure system design worksheet along with the profile plotter. So again, here we had our well, our pressure tank buried below frost depth, and then our pipeline running up into this pasture to this trough here.